All right, hello and welcome everyone for today's webinar. I got a really fun and exciting webinar planned for you guys talking about a really awesome project that combines both using SLAM data as well as some use of tripod-based terrestrial scan data, and really talking about how we can bring all of that together to produce impactful BIMs, especially in very complex environments. So again, super fantastic, really excited to show this to everyone. So I guess let's go ahead and dive on in. So a little bit about for today, meeting our guests. So number one, I'm Trevor with ClearEdge 3D. I'm part of the industry strategy and relations team. I've been at ClearEdge for quite a while, since it was a small little startup with just about a couple people. Fun fact about me is I am also really into whitewater kayaking. I've actually got a background in GIS. So Michael, I'll let you introduce yourself. So go ahead and take it away.
Sure, thank you. I'm Michael Warren with AECOM. I'm the Associate Vice President of Digital Practice and Technology. My focus is on innovation. I have 27 years experience in the industry. That includes construction, code enforcement, manufacturing, and architectural design. I've been working with scan-to-BIM technologies for about 20 years. And I'm a registered architect with experience in critical environments, transportation, and commercial architecture.
Perfect. Thank you, Michael. And then Anthony?
Hi, I'm Tony Mazzocco. I've been technologist piping specialist at AECOM. Approximately 18 years experience generating 3D existing condition models from point cloud data. And I specialize mostly in mechanical systems, MEP, primarily piping systems. Spent some time as a mechanical piping designer designing some natural gas facilities as well.
Perfect. No, so let's go ahead with introductions and then move on to a little bit about kind of some of the housekeeping for today. So for the housekeeping, number one, participants are going to be muted throughout the presentation. Number two, if you do have questions, please do type those into the chat section and go to webinar. We'll have a QA section at the end where we'll go through and basically answer any questions that you might have. Second, or I should say fourth, the webinar is being recorded for today, and then we plan on sending out the recording link. So that way, if you come in late or anything like that, more than happy, you'll have the full recorded webinar. So with that, I guess let me go ahead for our next slide, turn that over to you, Michael. So,
thank you very much.
All right, you should be presenter right now, Michael.
No, go back to your screen.
Oh, whoops. Let me
We're going to go through those. We're going to go through 3 little slides there before I'll actually go and present.
All right, getting a little too ahead of myself. All right, perfect. So yeah, I guess.
There we go. All right.
Perfect.
So there's going to be basically three components that we're going to be discussing here today: the reality capture side of what we do, and as advertised, we're talking about SLAM technology and terrestrial technology. And in the instances that we're providing, part of our practice that we've recently implemented is the use of a Navis VLX, in addition to our Leica RTC 360 and our Leica P40. And the interesting thing that we found was data is data. So whenever we started investigating what to do with that data, if you go to the next slide, we had to think about what kind of operating environments we were going to be working in. So there are 2 critical aspects to what we do. One is the mobile workstation. I'm not going to read off the list, death by PowerPoint, but basically mobile workstation power that we use on our production teams is listed on the left. And then we have desktop power, and that's really the workhorse behind what we do. Dual Xeon Gold processors, multiple hard drives, gives us the ability to collect and bring in all of this massive amounts of data that we use, get it processed, get it registered, get it presented, get it represented to the team in E57, gives us the ability to create the recap files from the E57 and also use it downline for products like Revit, Civil 3D, MicroStation, Open Roads, etc. Next slide. The core of the processing workflow that we're going to be discussing are the 3 components that you see on the screen. Tony's going to discuss a little bit more about what he does whenever he's actually in the environment modeling. But basically, we use the Leica Cyclone products. And I'll be showing some screen examples here in a minute. We also use Recap Pro, and finally EdgeWise. That's the Clear Edge 3D product, and that's where we actually do extractions for QA purposes, but also extractions for modeling purposes. So with that, now you can turn it over to me and I will share my screen.
All right, let me go ahead and pass it over to you, Michael. So there you go. You should have presenter right now.
Thank you. Get back over there.
All right, perfect. And we can see it.
Great. Okay. So Tony and I are with what we call the Digital Practice and Technology Group inside of AECOM. AECOM has made a push towards digital in the past few years, this digital transformation that everybody talks about in the industry. We've actually been at it a while, but we formally have a group here on the that's primarily located on the East Coast, but we work, throughout all of North America and provide services globally as well. The interesting thing about our group is we're made up of professional land surveyors, scan technologists, BIM technologists, architects, civil engineers. We have some very interesting other people with biological engineering backgrounds and nuclear backgrounds as part of our team as well. But we're a pretty well-rounded group, and we represent, again, this digital practice and the use of technology in what we do and how we represent it. So, quick agenda. We're going to go over a safety moment, which is something typical that we do at AECOM. We're going to go over the process, visualization, EdgeWise extractions, the Revit modeling, which will be covered by Tony, and then I'll come back and do model fidelity and level of accuracy checks. And Tony will be joining me for that as well. So, safety moment. What I have on the screen, you guys may have seen this before. If any of you were at RCN a couple years ago, I used this same moment to represent artificial intelligence or technology, or what AI can be expected to do and what it cannot do, and a precaution about that. These are images of blueberry muffins and chihuahuas. And a computer cannot tell the difference between the images. It couldn't extract and be able to recognize through feature recognition whether it was a blueberry muffin or whether it was the dog. We try to be mindful of that in our group, because as we try to tell our clients, if you can see it with your eyes, you can see it with the scanner. The scanner can only pick up what it can see. It can't ascertain what a pipe is, what type of pipe it is, what type of duct it is, what type of air is flowing through that duct. Is it exhaust? Is it return? Is it supply? It can only represent what it sees and what it measures and what it captures. People have the expectation that there's artificial intelligence involved in reality capture, and we try to caution our clients to make sure, because of this particular slide that I'm talking about, that they understand fully what the expectations are. So jumping right into it, what you're looking at on the screen is an image from Cyclone. This is a very large image. It's a portion of an airport, but the reason why I'm using this compared to the project that we're going to present on is because things are a little bit more clear and easy to see in this representation. And this is the mixture of the SLAM technology and the terrestrial technology. So what are we looking at on the screen? Obviously all the points, right? But what I want to point out is, if everyone can identify and see the green and blue inside, there's a path going around. That is from the VLX. One of the things that we learned, it happened just one instance, one scan opportunity. By accident, we weren't able to get through a door. We weren't able to complete the loop. So we had some incomplete data in one portion of a building. It was a small facility, but it was the first time using the VLX, and the door was locked and we couldn't get access to complete the loop. But it's very important when doing this and working in this environment that you set up quite a few things. First of all is control. We always start with control outside of a facility and then work our way inside. We also set control vertically. That includes stair towers. They're very, very important for vertical control. But then we have multiple control points and targets that we use throughout the interiors for the registration process itself so that everything aligns. In this instance, because we're bringing data in that would represent itself in two different spaces, we manually align in the X and Y coordinate and then use the targets to get our Z coordinates and everything aligned. And with this, we have a quality assurance process. So this is just a larger view where you can see the density of the information as it overlaps. And if you look at it inside there, you will start to see some of the control points identified. E1, E2, E4 shows up in this one. E3 is in a different location. But it gives a clearer picture of the path and the overlap of the data and the importance of the accuracy of the information that both devices are capturing. This is a three-dimensional view, same representation, still done with Cyclone Register, but this is a representation to show that the data does overlap, not just horizontally, but vertically as well, and it registers itself in a very clean manner. So you get a very, very rich experience for what you have or what you're going to use and use downstream. The devices are great independently, but they're even more robust when you bring that technology together. There's two reasons. The first is with the VLX, you get the capture with speed. You know, people are always concerned about speed and project delivery. That's a big concern. The VLX captures that speed. It gives our team the ability to start working much faster. Then with the RTC, we get the high density and we also get the imagery that goes along with it. It's just another zoom in where this time you can see point E3, but it identifies the path and gives a good representation of how the data actually comes together. So for the project that we're going to be talking about and we're going to demonstrate today, this is from Register 360, and these are the capture points that we took with the RTC. The walking path, I was trying to get a really good visualization three-dimensionally for the walking path. It didn't work out quite as well as I had hoped, so I'm still going to be working on that in the future. But this is a facility that's 150 plus feet deep into the ground and has some above ground structures. So we were able to capture that, and what you can see are the density of the points and the scan locations for the RTC and for the P40. So what was important about this? The importance was the assignment, again, of those datum points or those stations or the targets, right? So you can see the red crosshairs on the wall. That's a representation of one of the locations, the center point of the target. You can see the sphere where the camera was set up. This is the vertical control in the stair towers. You can see 3 of the green crosshairs. Those are 3 of the control points that we use to triangulate to get that information as we work our way up and through the stairs. And you can see from these images, you know, nice and clear. But again, this is coming from, instead of Register, this is now out of Cyclone 360. This is just a quick visualization of the encapsulation of all the data that was captured. I'm going to show 2 types of the data. One, what it looks like, which is what you're looking at on the screen, what was captured with the VLX, and then a smaller portion or a smaller snippet of the building. It's going to take a little bit of time to open up, but that was actually captured with the RTC and the P40. These are just some quick shots that were taken to represent the use of the target and the controls, but the image that you see on the right is a representation of just what the SLAM data looks like from the VLX inside of Revit. I was very pleased whenever I saw this image, because it gave the ability for, you know, Tony and Matt and the rest of our team to actually start to work and validate and start to get structural elements in, start placing stairs, start getting some of the critical items that were easy and capable of being seen. This is a view of the floor plan that came from using the VLX. Again, very clear, nice and crisp. Things are nice and refined. Similar view, data mixed. I was in a rush whenever I compiled this, so I didn't give it time to finish rendering. It takes a long time whenever you're mixing this information inside of Revit to get everything to come up clean. But you see it's much more dense, much more populated with information. There's more definition. It's easier to see objects, particularly small objects, things like small pipes or small conduit. And that was very important in the workflow and part of our workflow process. And with that, I'm going to switch over to a visualization. Everyone should be able to see recap.
Yep. We can see recap.
And this is representation of what was captured with the VLX. Very clean, very nice. Not as dense as what we would see whenever we would be utilizing the Leica products in a terrestrial format, but usable and very good as well. What's that?
Yeah, but that's not, I guess, to what you're saying, this is a complement to your Leica.
Exactly. But it gives the ability to start working early, as I stated, because it's clear and it's clean. So the team can actually start to initiate what they're working on, what they're trying to do, what they're actually trying to accomplish.
And if you just had the spitball, like, what would you say, like 50-50 VLX versus RTC, or like 60-40? What would you think the ratio of using the instruments for capture was?
Well, I know that it was one day of capture with the VLX and then about a week with the RTC. So
okay, wow.
Because there were just the amount of points and the amount of data that actually had to be captured and gathered with the RTC to make sure that it was as clear as possible. I'm gonna just switch to a black screen here so I can just swap something out here real quick. You have to forgive me, I'm operating without a mouse, and I am not one of the guys that likes to use the touchpad on a keyboard.
Yep, looks like we can see, looks like you got your new recap project open up right here.
Yep, and what we're looking at here is just one floor. We had to break this apart because of the density, but this is just one floor that was captured with the RTC and the P40 again inside the stairs.
Wow.
And you can see the difference in the density of the points, clarity on the objects, right? Can actually read elements inside the points, which was important, but particularly whenever we work in very dense locations to get a good visualization of what's actually going on. And then obviously we have all of our mirror balls where we can actually get the real view. And you can see from the plan view that's there, just the number of locations where we actually set up and conducted the scans whenever we were working.
No, I think, again, this is the I think the key thing with the traditional tripod-based systems is just that beautiful, sub-millimeter accuracy you get for documentation purposes. But again, coming back to the earlier point, it's not always like you need that. And that's where the SLAM systems for general mass data capture, I think, are a beautiful complement, so you almost get like the best of both worlds.
You get the best of both worlds, but it's the use in the right application. And as I said, that speed of actually being able to do the work is what's important. So what we're all here to see. From that information that I just showed you, this is just one floor that was brought into EdgeWise. And it was the actual floor that I was showing. So when you saw the second recap imagery that was taken with the Leica products, this is the result of the blend of that information between the SLAM technology and the terrestrial technology. What was interesting about this is when I just ran the SLAM technology by itself, there were some limitations with this diameter of the pipes it was able to pick up. So we were able to figure out, okay, we do have limitations when we're doing feature extractions with the SLAM technology, right? But it was still very, very nice range of piping information that I was able to get to Tony very early so he could visualize. And because we had done the whole building, it was very easy to get that over to Tony, say, start analyzing this, make sure you can visualize it, and he'll talk about that to be able to model around what the elements are once they're classified and identified. But this is just a representation of all of that. And the nice thing about it was taking the database information. Oh, if it's going to let me open it. Let's see if it's going to do this. No, that was the wrong one. All right, it's not going to let me open my database. But basically, with the database turned on, it's actually really dense in terms of what's there. And if we go to the pipe editor and we look at the smart sheet information with the part infos, gives a good example of the sizes. And I'm going to pull this off the other screen. It's going to give the example of the sizes that we were able to pick up. And you can see there's a lot.
No, that's a again, one thing kind of, I guess, with having modeled some of the SLAM data set myself, I know that was my main gripe, was the SLAM data definitely is at the moment noisier, like has fuzzier, and so there definitely is that limitation for how small you can go. For anyone curious, and I'm not sure, kind of the number I found was anything under about 4 inches roughly in diameter. It was just too fuzzy, and I couldn't get to work with. I couldn't get basically accurate extractions. Like
and that's what we found. We were at about 4 inches, was where we had found the limitation, and we had some issues with things that were over 12 inches in size.
Yeah. No, but
whenever we went, slam by itself. But here you can see that we have very small diameters from that blended world, right?
Yeah, and that's to me one of the most unique things about this is that blend and the fact that, like, again, you pretty much were able to use that RTC or that tripod-based data to complement the SLAM, and I think those pipe diameters speak for themselves. And that the resulting point cloud, again, you were able to basically extract out. It didn't really matter the diameter; it was able to find it, automatically just from the cloud itself.
And that's what was cool. And there's one caveat that I do want to warn everybody about with this process, because you have the SLAM data mixed in. Even if you pick structured workflow, It could be a structured setup with an E57 or a recap file. If you pick structured workflow, EdgeWise understands that the E57 information is also contained from SLAM technology, and it uses the unstructured workflow instead.
Yep, and that's, it is actually kind of something interesting that when you blend the two together, like if you had like the resulting E57, it's just, it almost like the unstructured side of it wins, regardless of whether or not you have the majority of tripod. Again, just the way it looks like the file structure is. But even more so, I think this was also kind of this project itself was actually one of the first big major, I guess you could say, kind of pipe models that was generated from the new SLAM algorithms that came out from EdgeWise 5.7 that was released not too long ago. So.
Yep, I downloaded it, made sure I used it, and ran it. And this was, as I told you guys, this was one of the first instances where I had actually used 5.7, and I was very, very pleased with the overall result that we got. Just looking at one entire file, I was exceptionally pleased. As I said, the amount of pipes that we're dealing with and talking about and the size ranges that we were able to get were enough to hand off and give over to Tony and get him started on some visualization, but also give me the ability to start doing QA on the accuracy of the points, and by doing the root mean squared analysis, with ClearEdge itself, with the EdgeWise tool, finding out how accurate we were, right? As far as using the automation tools and how much noise had actually affected the extraction of the pipes. And it was very, very impressed. I can probably pull some of that up here a little bit later, but I want to hand it off to Tony right now and give Tony the example to walk through what he does on his end, basically, once all of this is brought together and handed off and transferred over, what Tony then begins to do with his team.
All right, perfect. All right, Tony, let me go ahead and I'll pass you presenter, and you should have presenter. All right, and we can see the screen.
Okay, great. Okay, thanks, Michael. So what I did on my end begins generating the Revit model you kind of see before you here is we started this model from PDF plans. We had a handful of PDF plans, not very much information on them, enough to give us some walls and locations of doors and levels of floors. But it got us started. It got us a Revit model set up and with some elements. And then I received the VLX data, the process data, the VLX, and then I inserted it into the Revit file, and that allowed me to start to adjust the model to the existing conditions of the facility. And this is still, I'm doing this one, we're still out in the field scanning, so it was a nice jump start for the modeling to be able to start to really adjust to the final position, of this model before we're even done gathering the scans in the field. And I actually got a lot of information. I'm surprised I was able to set up, I'll open up the structure here. I was able to model in accurately this entire structure, from the VLX data. And I had all of this in here, all the architectural in here before we even got the data from the RTC, the blend. And as Michael mentioned, I got the export from EdgeWise and was able to put that in my model as well. And I had a jump start on the piping, which I can open up the MEP, a view of just the kind of overview of all the MEP system that was in this facility. And something to note, it is important to take in consideration the scope of the project whenever we're using these tools. The scope, there's different levels of detail in this drawing. Pretty much everything you see here was a level of detail of 200. So we really only needed this piping system and the duct work for more clearances than anything else. but we really wanted to focus on, I'm going to zoom in here a little bit to this red hydraulic piping here. You can see we have a lot more detail on that, and this is kind of what we were relying more on the RTC to capture, because some of this piping here is, 3/8 of an inch in diameter. We really needed to be able to, differentiate between a 1/2 inch line and a 3/8 inch line. So we really needed that more crisp data, I guess you could say, for that instance. But as far as the rest of the piping goes, a lot of this stuff was, extracted from EdgeWise, and whenever I got it into Revit, I had to do some classification of the piping and some connection of some of the elbows, to make complete systems. I can click on this stuff in Revit. I mean, it's all part of a system. So, here's the process drains here. Everything had to be classified. So that kind of helped, having that RTC data in here as well, just to kind of make everything, as accurate as possible. And so and some of the stuff was modeled manually, and to do that, just use some basic Revit commands, basic Revit tools, view ranges, sections, because the most important thing when modeling like that is to be able to manipulate the data to see exactly what you want to see. So that's pretty much it, in a nutshell, how the workflow with this model went. And
no, I absolutely love looking at this model, by the way, just with all the piping, and I think it's absolutely fantastic. Just kind of one of the biggest, I guess, highlights is, the introduction of EdgeWise into that workflow. Again, kind of using it almost as a springboard. So that way, instead of having to model everything from scratch, having EdgeWise basically pull out a good chunk of the piping automatically for you. Do you have any idea roughly about how much you think it kind of pulled out? Like, 40, 50% or a little bit more than that?
I would say around 40, 50%. Probably closer to the 40% range. A lot of the stuff, like I said, some of the smaller stuff, our main focus, that was mostly manual, but it did pick up some of these lines, and that helped in the modeling, because it almost acted as like a pipe finder, if you will. I found the center line of this line here. Say it was this one line here. There was a cylinder here, and it helped me, identify, okay, here's the main run. I mean, it acted as a, and that's kind of how we use it as a QC process too. We'll get into that later, but I mean, it really helped, especially with some of this stuff that I really only needed a level of detail at 200. There was very minimal work that had to be done with these lines once it was in Revit, pretty much just classifying the runs, So, I mean, it was a huge time saver.
Yeah, and I think that's to get those results of what you're seeing for, it's not, I guess one of the big things is when people say clearage, they're like, oh, automation is all this, and, model your, it doesn't do that. And one of the most, I say, critical things is good data. Having good data, that way the software can really leverage that point cloud and then find you your pipes, and that way you can really get the results that that you guys are seeing. And I think that speaks to just how important that data collection is up front to make everything downstream really kind of work and get the most out of it.
Exactly.
Yeah, and if you think about our logo that I showed at the beginning, it's a Mobius strip. And I don't know if you're familiar with a Mobius strip, but basically, if you made one out of paper and you took a writing utensil and you put it on the paper and you started at a point and you drag the paper across the pen, you end up where you started. And we always think of the end and the beginning at the same time. So our modelers know how to scan, and our scan technicians understand all the practices that we utilize when we model. So there's a good trade-off there from beginning to end, because the modelers can educate about where to get capture points to get this kind of fidelity when we're modeling, and where to get the setups for when we're modeling based on what we need. And that's critical, and that's very important, but it also gives us the ability to, as I said, start work earlier and then utilize it as a QA process while you're actually designing and working through. And Tony and Matt and the team, I think, did a wonderful job here going through this. And Tony, talk a little bit about the visualization side that helped you assist on being able to identify what type of pipe was what and what was conduit and what wasn't pipe.
Sure. Yeah, the visualization we used. We used the scan bubbles and recap, and we used a QPix actually online. We took some images down here too, and we were able to see, the piping systems labeled, from the labels on the pipes themselves, and really helped us get an idea. Because being a piping designer by trade, I'm always looking for, what system is this pipe? Where does it start? Where does it end? So that same philosophy kind of comes into play when you're actually when I'm actually modeling the system, and that's really what helps, the accuracy in getting everything in the model.
I think that's actually a really kind of interesting point you just brought up there, is that it's not even, even though LiDAR, I would say, is maybe like, let's just say like 70–80% of this is also the value of images and, doing your BIM, having that image data that can help with that, making those decisions as you're going through for information purposes. I think that's actually another, I like personally, if I'm doing, scanning, unless it's called for, I'll usually leave images off. I work in grayscale quite a bit. But I definitely think that is actually an extra, just having that additional data to help with that modeling. I think that's actually a really good point that you bring up right there.
Yeah, and that's what we learned on this project too. I mean, these files get so big and they get so hard to work with. We actually know for the future, we were going to use this QPix software. Or I don't know if anybody's familiar with that, but we took a camera out there and took pictures, and we walked through it in QPix with a background and everything. I mean, it makes it real easy to kind of walk through the facility as you're modeling, and it drastically decreases the size of the point clouds, because now we don't have the images in the point clouds. We're utilizing this standalone, cloud-based software to view the images. So kind of just that kind of works into the workflow, and for future projects, we know we need to know the scope, what tools we're going to use in the field to capture the amount of detail we need according to the scope, and we know what software we're going to use and what tactics we're going to implement. So
yeah, no, and that's, again, I feel like that is a quite often or somewhat overlooked piece, is especially people who are getting into scanning. It's, oh, here's your recap project on like a like a USB stick. But as SLAM and these mass data capture like instruments become more prevalent, I would say, and where once upon a time like 30 scans was a lot. Now it's like 1,500, 2,000 plus scans. That's kind of a whole, how do you manage all that data?
Right.
So,
well, if Tony, had wanted to bring up the point clouds here, they were broken up into just tons of files, because the point cloud, as part of this in the background, had to be broken into parts east and west for each floor, because we were talking about 1.9 terabytes of information. So.
Whew.
And it's a lot, and that again goes back into what I was talking about having the right type of machinery to be able to, work your way through.
Oh yeah, no, that's definitely, you need some processing power just to work with that amount of data. And I also think it goes to show, it's as these point clouds, I feel, get bigger and bigger, and tackling more stuff with them, it's becoming harder and harder for the human to, it's just so much data. I feel like just from a human perspective, it can be a little bit overwhelming. And I think as this continues to evolving, we're going to be seeing more and more automation, basically being deployed to help assist the human just to make sense of, these terabyte plus files that we're getting almost,
Yeah, it takes a while to refresh. And again, whenever I did the SLAM based, it was easy because I had one model to go in the EdgeWise with. But once we got to that terrestrial being introduced to the party, I had to break it up into parts.
Yeah.
And the great thing about the horsepower with the tower that I had was, if I would have tried to accomplish the same thing off of my mobile workstation, when I ran the initial run, it took a day and a half just to create the database and generate extract the pipes. Whenever I did the same process on the Beast, basically it cut that down to about less than 10 minutes for each one of the scans. And it was, we were talking in the range of 107 steps. One of the files I had a little over 200 steps. But it reduced that time dramatically, banging the stuff off. It was fun to actually watch, see all of that actually get produced that quickly. And then we were able to assemble that. I was able to assemble that into a separate model for again, the visualization purposes. So it's pretty cool.
Wow. Yeah, no, I think I'll say you're making me a little jealous over here on my kind of older laptop I got going on, old reliable.
So we'll go into, we were talking about QA, and you can see the points there, and they're actually still loading in the background. So, it takes a while. We can go all the way down through the building with that. But with that, if you want to go back over and make me the presenter, thank you, Tony. I'm going to go into some of the QA processes here.
Yep, let me go ahead and I will make you presenter, Michael. Michael, you should be presenter now.
Now, very good, thank you. And what we do is we go through a multi-step process. So, and I will bring up the ClearEdge information, but you should be seeing Celebri Office right now on the screen.
Yep, we can see it.
And this was basically the generation of IFC files from the modeling work that was created. And these were checked with building check files to make sure that there was good fidelity inside the models. That everything was representing itself and it was well defined as far as the LOD. And you can really start to see the representation of all of these various systems and pipes and conduit and things that Tony was talking about. And this is part of what I enjoy because that's part of my responsibility is to do QA on these things. And it makes me very happy whenever I get building check files where everything turns out great. It's very pleasing and very rewarding to know that the team did such a quality job in the execution of what they did. So that's just one aspect of quality assurance. I don't know if that's part of people's normal workflow or not, but it's something that I do as general practice and as a general rule whenever we're talking about modeling. The other thing that I want to bring up is the use of Navisworks. And Tony, I don't know if you have Navisworks open, but if you could open it, or at least your reports, one set of your reports. Let me drag Navis over. And this, I'm not going to be able to show. That's why I asked Tony to bring up the reports. But with this, for the sake of time and the size of the point clouds, we have the same instance where we actually run class detection on the elements against the point cloud themselves. And that's what I was asking Tony to bring up.
Beautiful.
And then that gets into the level of accuracy. And it ends up being a really, really massive file when you do this workflow and you're bringing the point clouds in. But you know, again, that's part of the quality assurance process, and that goes back and ties back into utilizing, you know, the EdgeWise product, which becomes important because when I go to my part info and I do my QA, these numbers are really good.
No, just for everyone, the RMSE is, again, just to reiterate, that's like the fuzz, like that's basically root mean square error value, which is the distance of error there is in the pipe fitting to the point cloud. And then the other one is coverage, which is the percentage value of how much the outside surface of the pipe is covered in points. So, and looking at this, those are some nice, those are looking like some pretty good coverage values.
And again, this is run on each one of the various levels throughout. And again, it just deals with the quality assurance of what's there.
Yeah. Again, I
sure
just
get it in.
Just to come back to your the Mobius strip example, I think it's a beautiful thing to show, like how that, you know, the end deliverable that you guys, that's absolutely fantastic, but it all starts back at the beginning with ensuring that, you know, proper data collection, control, all of that is basically necessary, because if you don't have that up front, there's no way you can produce, you know, such a great final product.
Tony, were you able to pull open one of the QA reports?
Michael is still working on it.
Yeah, that's one of the.
There's a lot of, yeah.
That's one of the deltas about whenever you're classing points against solid objects inside of Navisworks. You end up with, you know, tens of thousands of lines of information.
Yeah, no, it's perfect. I guess, yeah, we can go ahead, and I know there's quite a lot of questions that I can see kind of percolating in the back in the QA section of GoToMeeting. So I guess let me go ahead and switch this over real quick to one moment. And if I guess Michael, Tony, you guys ready to take some questions from the audience?
Sure.
All right, let me go ahead and 1 second just to, oops, that's not the button I want. All right, trying to everything nice and organized here. So give me 1, 2, 3, 2, 2. Right, and there we go. So we got our, switch back to my final slide. There we go. All right, so one of the biggest questions is actually about control. So we have Tobin, who looks like he's, question was, do you traverse in and tie all of your control points in with the total station?
Typically, yeah, we use the team uses a total station to gather and collect their base point basically whenever they start, and then they work their way through from that actual spatial base point. Now, what's interesting about, you know, the question is there are times that we capture everything in real space, but there are times when we have to deliver projects where we can't utilize that real space and we have to reset the coordinates to Revit datum, which is basically making the adjustment of where that actual origin point resides. Because if anybody knows, you know, once with Revit, you get outside of 20 miles, anytime you're geospatially referencing everything in Revit, it's going to be outside of 20 miles once you put it on a coordinate system. You have to make adjustments. So there's other tricks that we do whenever we actually do the surveys, where we'll bring the data in and capture points inside of Civil 3D, and then we'll use the shared reference point tool and then go back and reset the coordinate system inside of Revit to get it on datum and put it into control.
Perfect, perfect. I guess next question is actually about the slam capture, which was basically how long did you guys do the captures with the VLX? And then kind of my own little question is this is, did you guys do it all as one giant capture, or did you basically do kind of each floor would have a loop, something like that, kind of break it up into multiples?
Whenever it was the way that it was done, if it was done by each individual floor, and then the stairs, you know, again, were walked through. So I guess to answer long story short, it was one big amalgamated capture.
And then you just I think, yep. And then did you process those captures separately, or did you just chuck all the data at once in the cloud processing?
I received one file from the field.
I see. I guess let's see, just trying the trying to sort through some of the questions here. Another question is actually, have you tried to turn the point clouds into a mesh for easier class detection and better visuals?
Okay, that's an interesting question. That's a really interesting question. And I'll answer it personally, and I know that there are people on this call that would disagree with me, but my experience with the mesh is that when you actually generate meshes, now there are software platforms out there that do a great job, Preview 3D, you know, there's others that do a great job in generating mesh models for viz purposes, very high fidelity models, which are great. We utilize those capabilities and technologies whenever we have to get clients to visualize things. But I'm not personally a fan of using mesh inside of a modeling environment because I find that it bloats the file and it gets the file to a very unusual place as far as the team being able to work and do the work that they have to do. We've modeled some very complex buildings in the past with very high ornamentation and statuary and other things that had to be part of the model. We generated meshes for those and incorporated them in the model, but they had to be their own separate files because they exceeded, say, file limits. You know, we were talking Revit files that were, you know, when we initially had done some of these buildings were, you know, 500 megabytes, 600 megabytes in size just with the mesh. And that's an unhealthy size whenever you're trying to accomplish utilizing a Revit model. The max is between 250 to 300 as far as a recommendation and best practice. So it depends on the application and if we're using the cloud or not. But I personally don't subscribe to mesh modeling on a local basis, again, because the files are just incredibly large.
No, perfect, Michael. That'll be an interesting one to have a few drinks over at RCM this year, if anyone wants to discuss that one a little bit further. I say that jokingly. Let's see. Another question is, would you mind telling us, I guess, a little bit more about the actual QA/QC step for kind of ensuring that you guys like didn't miss anything as far as like the modeling process goes?
With the modeling process, that's what the Navisworks was for, and there's two checks. The first check is obviously the interference check to make sure that nothing was modeled out of place, right? So you can do that inside of Revit. And ideally, nothing should be touching because we're modeling what's there, and unless the objects actually touch, right? But nothing should be running through another object. So that's the first step in the QA process, is that visual inspection, allowing Revit to do that. But with the QA process with Navisworks, as I said, it takes a long time, but you can clash points against solids. And we clash the points against the solids to make sure that, and it gives us an accuracy report along the solid for where we're in tolerance or out of tolerance. and that's set by deliverable. You know, how accurate do we have to be? Is 1/8 of an inch acceptable to be off, or is it 1/4 of an inch? Are we talking about, you know, can we be off by a couple inches when we're talking about civil works and elements in the outside built world, as far as horizontal construction and things under the ground? So that sets up the rules and the governance inside of that QA process. And as I said, you need some horsepower, because it actually will bog down your machine, because it's analyzing all of the points along all of those solid objects, and that generates the accuracy that's there. Tony, was your report able to open?
It's still loading up, like you said. It's slowly loading points in, and it's my PC's screaming over here, so I'm not sure it's going to finish up or not. But kind of to add to that, Michael, I mean, we do, as the modelers, we do our own form of a manual QC, if you will, as well, before we hand the project off. You know, we go section by section, floor by floor. We adjusting view ranges and section depths, and just to ensure that everything has been captured that way. You know, so that's kind of an extra check we do on our own end.
Yes. Another question is, let's see, kind of more, I guess, some general kind of Olympic questions is asking about kind of the hardware and timelines. So just kind of to reiterate, it was basically a day of scanning with the VLX. Then you said it was about 2 weeks scanning with the RTC 360 and PC.
With processing, with processing included.
Okay, so, you know, day, 2 weeks, and then how long did the actual, I guess, modeling take?
Yeah, go ahead.
Yeah, I was gonna say, if I can remember correctly, I believe we had about 4 or so weeks of modeling, 4 to 5 weeks of modeling. And that's starting from, you know, week 1, or, you know, day 1, whenever we got the PDFs, and, you know, through the receiving the different the structured and unstructured data. I mean, I think it was about 4 to 5 weeks.
4 or 5 weeks of modeling, and probably what, like another about week or so of QA?
Yeah,
approximately. Yep.
Okay, so all in all, I guess you could say the total timeline is like what, a day, 2 weeks, and then doing some math.
4 weeks, another week, so about 7 weeks.
About 7 weeks from kind of roughly about start to finish to produce the final deliverable. All right, and then just kind of a quick one. Diameter cutoff for EdgeWise for piping. What, under with the VLX is about 4 inches. Over, trying to think, what did you guys say you kind of found for kind of the larger diameter stuff?
I found the max anything over 12. It just didn't like it.
12, yeah.
I'm going to run some other tests, but with some much larger diameter pipes. This was a particular pump station scenario, but we have some treatment plants that we're going to be doing with some very huge pipes. I want to see if I can run it again and get it to pick those up. But in this instance, anything over 12 just didn't generate.
Interesting. I know from my own personal experience, it caught actually a lot of the larger stuff was fine. In fact, I was actually even able to model some tanks from VLX data. But I know it definitely, my main gripe, I guess you could say, was definitely on the smaller stuff. And like I said, anything under like 4 inches, like the smaller little lines coming off the tanks, that's where it was just too noisy and I couldn't work with it. But the larger stuff for me, I know in my experience, it worked without issue. Let's see. I think there's a few other questions, but I think we can kind of take those a little bit offline. Let me just do one more. Oh, actually, here's an interesting one. For the modeling purpose, did you guys actually have a team of modelers for that, or is that pretty much just you, Tony?
It was a duo. It was myself and one other colleague.
Okay, so that 2 guys, or both of y'all kind of working on it, and that was about that 4-week time, that 4-week time frame, right?
Yep, exactly.
Okay.
But you're
And then,
talking mixing in with working on other stuff as well.
I
So
see.
it
So
wasn't
not
that
head
it wasn't
down.
just it wasn't that they were doing something every day in that particular model. The time frame would have been cut down substantially. But we asked those guys to do a lot whenever it comes to pipe layouts and designs as far as mechanical stuff. So they're wearing a lot of hats and working on a lot of different deliverables at the same time, because some deliverables go to clients, some deliverables go to our internal clients, right? The design teams need them. So we have to utilize Matt and Tony's time to get the mechanical systems and the hydraulic systems and other things in place so that those teams can get a jump on their designs or demolition work that has to occur inside the models.
Perfect. I guess I know there's a few more other questions. We'll go ahead and we can follow up with some of those other questions through email. I guess any other final closing remarks? I guess Tony or Michael.
Nope. I hope we covered and it was interesting. And again, yeah, definitely at RCN we can have the debate over mesh. As I said, cloud-based meshes are great. Localized meshes, just somebody's going to have to prove me otherwise. They just get very large and unwieldy. But other than that, I hope the workflow is there. I hope you guys try to experiment with this. It's a really positive thing. It's going to become general practice for me as I do my workflow. And again, it's also a great quality assurance check process to do some of these extractions and take advantage of the opportunities what software can do. Down the road, we'll be doing some structure and mechanical extractions as well. So that's going to be the next test. The piping and conduit was big early on, but I want to take some of the SLAM technology and use that with ducts and structural. See what we can manage with that.
Perfect. I mean, I think really a pioneer in this field. Definitely interested to see kind of the results that you guys come up. I mean, this is kind of one of the first big, I think, blends of using SLAM technology with traditional tripod-based data. So really excited that you guys are both able to join us and kind of share this with everyone. Again, I'm sure a lot of people are very interested and kind of really impressed at the results that you guys are able to get.
Great. Thanks for having us.